Okay, so last week we took a look at what was the average home price in Pendleton based on a sample that was sort of random from some online data about home prices. And we came up with an average value, and then we increased the confidence interval and took a look what happened. This week we're going to do a similar thing. So some people were surprised that the average cost of a house in Pendleton right now in the current market seemed quite high. So what if you're looking for a house in the lower end of the range? And so someone might want to know, well, what percent of houses cost under $150,000? Okay. So we're going to try and estimate that based on our data. Then we'll take a look at our confidence interval and decide if the interval is too wide, how many houses should we sample to get a better prediction on the interval of the percent of people, percent of houses that are under 150,000. So I'm going to jump into my data and start doing that. So same exact data we have from last time. This time the difference is we are looking at the proportion of houses under 150,000 as opposed to the average value of the house. So we're making a totally different interval. So to do that, I'm going to have to count how many of these houses are under. So don't try to do the sheet at the same time as me. I'm just going to demo it, and then I'll help you guys do it. So fortunately, Excel has a command called COUNTIF. And so I want to count things in this column, comma, if, quote, they are less than 150. Close the quote, close the parenthesis. And then I'll say, oh, there's 17 of them that are under 150. And then I know there's 50, but I'll just double check. I'll say, can you count the numbers in this column? And remember, clicking on the column heading is only safe if there's only numbers in the column that are related to what we're counting. And it says, yeah, there's 50 numbers. So then P prime or P hat, the population proportion, is always how many favorable outcomes divided by the total number of outcomes. Q is the complementary probability, so that's always 1 minus that. So that should be what, 66%. And here I'm going to go for a 98% confidence interval. Blow that up a touch. Alpha is the tail probability, and I have a picture of that over here in the next tab. So in the next tab, I did all the calculations in case you get stuck on anything, but I want you to try and do them first. So here I'm putting 98% in the middle. I need to find the z-score, the point on the number line, that contains 98%. And the norm inverse formula told me it was about 2.3263. If the tails have 2% to share, then each tail gets 1%. Right? So that's my alpha over 2. So I'm going to go compute those over here. So alpha is just going to be 1 minus this guy over here. And alpha over 2 is just the above number divided by 2. To get the z-score, that's the tail probability, that's the norm inverse. And so I'd say, give me the norm inverse of that tail probability. The mean of a z-score, remember, is 0, standard deviation is 1. And so there's my 2.3263. Now it's giving me the negative number, which kind of screws me up later. So I'm just going to sneak in there and say, please make it positive by multiplying by -1. All right, error bound on the mean. Remember, that's the z-score times what the binomial normal thing tells me to do. I'll write that down in a minute. So that's going to be my z-score times the square roots of p times q over n. And so here my margin of error is about 0.16. And then I just do a quick calculation on the side. Remember, we can always look at the percent error. And the percent error is always going to be the error, margin of error divided by whatever number's in the middle. In this case, 2 prime is in the middle. And all this data is on the website. And you guys will get to play with it in just a minute. So my lower bound is going to be equal to my P prime minus my margin of error, and the upper bound is going to be equal to my P prime plus my margin of error. Okay, so now I have an interval. So here's my belief. I'm 98% confident that the percent of houses in Pendleton that are under 150,000 is somewhere between 18 and 50%. Is that a big spread? That's a big spread, right? I'm 98% confident, which is great, but I have an awfully wide interval. So in this case, I can see that 16% spread is actually 46% of the middle, based on the middle. That's a wide margin. I'm not happy with that. So what I'd like to do is take all of this information here, and what's the only way? There's two ways I can make my interval better. What are they? I could make a bigger sample size, or I could decrease my confidence. Because if you decrease your confidence, then that is going to, let's see, how do I switch tabs here? It's not letting me switch tabs. Okay, here's my other tab. If I decrease the confidence interval, the confidence level, that narrows the interval. But who wants to be less confident? You know, that's not necessarily good either. So what I'm going to do is over here, let's see if I can minimize that. So come on, behave, would you? There we go. I have 100 houses here. And it turns out if I made my formulas right, I can just paste them in here. Oops, I did the wrong thing. Try it again. I'll blow this up in a sec. If I did these formulas right, I should just be able to highlight them, copy them, and paste them into the 100 here and see what happens. So let's see if I blow this up. So here now I only have a spread of 11% from the mean, which is only 27% from the center. So now my interval is between percent of houses and 52% of houses are under 150,000. That's better than before, true? But will a lot of people look at that and say, that's a pretty wide margin? Yeah. So then what we're going to want to do next is say, well, how many houses do I need to find to get a much narrower margin? So what would be a nicer margin? Instead of, what do we have? We have 11% here. We have 16% there. Wouldn't it be nice to see more like 5% margin? Yeah. So we want to then calculate how many houses we should sample to get a 5% margin. So I'm just going to write down a couple of formulas so that we can do that. So reminder, let's see, let's delete that stuff. The error bound on the mean, the EBM, load this up again. It's calculated. This is for a proportion, yeah. So we take our z-score, and then we multiply by the square root, SQRT, of our p prime times our q prime divided by n. And what we want to do here is we want to reverse that formula so it tells us what n is. And we did that algebra in class the other day. I'm not going to repeat the algebra. I'm just going to give it to you. So if somebody says, hey, I want my margin of error, this isn't EBP, sorry. We're doing a proportion, not a mean. I want my error bound on the proportion to be more like 5%, so 0.05. So to find the n that goes with that, if we solve for n in this formula, we're going to end up with p prime times q prime. So you want to write this down because you'll need this at the end of the lab. Times parentheses, oops, that's not a parenthesis, your z-score divided by whatever your new margin of error is. So I'm just going to call that E. And then we square that parenthesis. And you're going to double check this in a minute, but I calculated based on either the 50 or the 100 sample that if we want a margin of error of 5%, we're going to need to find between 500 and 600 housing prices to get a better margin of error. How many houses are in Pendleton? Well, there's like 17,000 people in Pendleton. If we say on average there's 4 people in a house, if we divide that by 4, that's going to give us roughly like 4,000 houses in Pendleton. On the market, there's maybe at any one time, I don't know, 10% of the houses are on sale, maybe a little more than that. So we're kind of edging toward the total housing market in Pendleton to get a good estimate about what the proportion is. So in this case, our theoretical experiment is kind of saying, well, you really need all the data to get a good estimate if you want a small margin of error. Otherwise, you have to accept the limited data you have and the wider margin. And that's just a reality that you have to face sometimes in data analysis. So the two big formulas we need to finish this off, we need to know how to find the error bound under proportion, and that's the z-score times that crazy square root. Like our margin of error, and we need to increase the sample size. And so this last formula down here tells us how to increase the sample size based on a desired margin of error. Now, does that value of n guarantee we'll nail our desired margin of error? No, but it'll put us in the ballpark of it. It'll take us from 16 to 11% off to more like 5, 6, or 4% off is what will happen in that case. So your goal here is to take the data that we have and do these calculations. If you need help on the calculations, there's two things you can do. You can ask me or look at sheet 2, where I have all the formulas worked out there. And then you're going to repeat it for the 100-house sample. And then you're going to calculate how many houses you need to find in order to get a smaller margin of error. And then we're going to state what those mean to somebody like my mother or a friend of yours who doesn't know as much statistics. Okay, so that's the overview of the lab. Let's get busy and help each other out. So I'm just going to wander around and help people.